awards. You guys, did you guys look up in the manuals to see what awards there are to go for?
Chairman's Award, design, I forgot what company holds the something design award. It used to be the Motorola design award. It may still be.
And then there's Woody Flowers probably. Right, or the Woody Flowers.
I still believe there's the Excellence Award.
This is the Rookie Team Award, which we can't get.
I'm pulling up the full list.
Okay.
No, no,
Yeah.
no.
But who's actually looked at that whole list? Sam? That's it?
I went off the list and I'm like, oh, nope, can't get that one, can't get that one.
Why not?
Huh?
Huh?
I think it was the video ones though. It's like
Right, the ones that you have to do some sort of submission. Yes, it'll take some work to go for those awards, but there are other ones that are based on what the judges who will be at the competition see in you guys. But I mean, if you think that's something that we'd like to go for, you need to come prepared, okay? And not just show up and just answer, well, just answer whatever question. But you got to know, have an idea what they're going to ask you, and be prepared to answer those questions, or let that guide what we actually do during this build season, what you guys actually learn before we go to the competition. So, since none of you guys actually looked at the list, could you please do that?
Would you like to read it off quickly?
Sure.
Okay.
So just the name of the award and what it takes to get it.
Chairman's Award. It's the Chairman's Judge Panel, and it's by representing the team who best represents the spirit first. Championship Winner Award, based on robot performance. Whoever wins the
Okay,
championship.
so a bunch of them are for robot performance. Most of them are not for robot performance. It's either based on something you submit to first, or the judges who will be roaming around at the regional competitions, their decision, okay, based on talking to you guys or about the team, about the robot, about your experience, okay? So skip over the robot performance ones. We know what it takes to win those, doing well in the competition.
Yeah. Okay. Xerox Creativity Award. Celebrates creative design or execution or strategy during play.
Okay, so if we go there without any kind of strategy, and we can't explain what our strategy is, the judges aren't going to think we deserve that one, right?
Engineering Inspiration Award, based on team's effort in advancing, respecting, appreciating engineers in their school and their community. Entrepreneurship Award, basically a team that has a well-developed business plan that's self-sustaining, so their club funds them, or their first team funds itself and doesn't need anything else, I guess.
Like Kickstarter?
Yeah. Excellence in Engineering. It's based on having advantageous machine features, engineering excellence and elegance. Dean's List, outstanding student leaders who have passion and effectiveness for obtaining first ideals. First Future Innovator Award, based on innovation and intellectual property creation during the first season. Founders Award, anyone who's contributed significantly towards FIRST as an organization, not just their team. Gracious Professionalism Award is based on who best exemplifies FIRST's idea / motto of gracious professionalism. Highest Rookie Award, oh whoops, never mind.
Too late for that.
Yep. Apparently there's only 2 rookie teams and we didn't get it. But, Imagery Award, attractiveness and visual aesthetic, without detracting from functionality, I guess that's what it is. Industrial Design Award, kind of the opposite. It's just very, like, the robot's design is very functional.
Not necessarily. Industrial design does encompass some aesthetics.
Oh, well,
Right.
it says form and function in an efficiently designed machine.
Well, form is the aesthetics.
Oh, okay.
Function is.
I guess it's less emphasis on aesthetics and more on practicality, so you don't have to make it pretty, it just has to look effective and clean. I guess that's more clean. A clean one. Alright, Industrial Safety Award. Team that progresses beyond fundamental safety and uses innovative ways to protect or eliminate hazards. What? Don't hit anything. Innovation and Control Award. Innovative control system or application of control components. Judges Award.
Impressing the judges.
Yeah.
Wait, go back to that innovation and control.
Innovation and Control. I'm just going to read it straight off this then. Award celebrates an innovative control system or application of control systems, electrical, mechanical, or software, to provide unique machine functions.
Right. So if we took a robot and all, right, its main control function was we took the standard kitted parts, joystick, we moved it, and then that made a motor turn. Is that gonna win that award?
We've already placed an order for, they just wanted to do PS2 style controller.
Okay.
So, nothing innovative, but if
Right.
they think that'll be better.
It's a
than just-
little bit out of the kitted parts box.
It's still pretty standard.
Yeah.
You see a lot of teams with that. But, I don't know, that's what they told me they wanted to do.
Okay.
Motorola Quality Award. Based on your machine's robustness in concept and fabrication. Regional Rookie All-Star Award.
Nope.
That's a judge's one though. But,
Rookie.
yeah, we're not.
Rookie.
Safety Animation Award. You submit a short animated film.
Okay.
Yeah, to them. Team Spirit Award. Award celebrates extraordinary enthusiasm and spirit through exceptional partnership and teamwork to further the objectives of FIRST. Also known as dyeing your hair weird colors and being way too crazy about the competition.
It's not just that. It's,
Yeah, I know.
it's your attitude.
Yeah.
I feel like the teams that have won that in the past were like the in-between ones where they didn't just look odd, but they were actually genuinely happy to be there.
Yeah, Ramona Rampage tended
get
to
that
get. They got it one year, I believe.
So,
But the people with the tiger, they're very
Oh,
enthusiastic tiger.
that.
Yeah.
yeah.
Who was dancing?
So I guess
like
that one's more about like a little bit of showmanship with the costumes and stuff, but
Yeah.
actually genuinely wanting to be there and
Yeah.
be very enthusiastic.
Mm-hmm.
Digital Media Award. Award celebrates teams that look beyond the team website, taking into account the numerous ways people search and consume for content.
Oh.
And yeah, the Woody Flowers.
So what does that mean? You just have a Facebook page?
Well, that's just for we actually have a Google site from
Yeah.
pretty much the conception of this team. We've had a Google site that has not been maintained until
Oh,
what,
the
a
first
month
one.
ago, where Kimmy took it over again.
We had a Google search.
Yeah, I didn't know that either.
Your
the
own
last
members
one,
don't know about your website, so they don't get it.
The last one is the Woody Flowers Award. Award celebrates effective communication in the arts and sciences of engineering and design. And it is recognizing mentors who lead, inspire, and empower those around them by using excellent communication skills. And that's all for this year.
Okay. So which ones are we going for?
Regional finalist!
All of them.
Except the safety.
Wow.
You know, we're never gonna get it if we're just like, oh, write that one off.
But
You know,
Yeah.
Yeah.
you already
Why
did.
aren't we gonna get safety award?
It's fine.
Huh? Because
We
what?
can go for it.
No. What? Tell me why you think we
I'm
won't
not
get
showing this
that.
video to the judges.
This is all a skit. We're acting. Is it still recording?
Yeah,
Yes.
Oh, okay.
It's always recording. Yeah.
Because we have a safety captain who's not even here right now.
I agree.
Are
I'm
these
kind of
judged
angry
during
about that.
competition time?
Some require a submission by a certain deadline sometime in February, for like the digital media and the, it used to be called the
Safety
website.
video.
Whatever. Yeah, any of the video type of submissions, but the rest of them, at the competitions, they'll have professionals in various fields, business people, engineers, management people, going around and talking to the students about their first experience, about what they went through to run the team, build a robot, all that stuff. And then they, decide the awards. So there will be 2 award ceremonies during the 3-day event.
Mhm.
So,
And Gary likes us to watch them to
Hey.
be a good sport.
Dean wants you to be there.
And that too.
Which
Oh, yeah,
brings me
Dean
up to
came in.
another point. We are totally going for the Dean's List Award.
Okay. What do you have to do to get that?
You guys all have to vote for me. Or give me. No, Dean's List Award is the senior award. So that's the one for having the seniors on your team, and they do it basically. You can nominate 2 seniors from each team for the Dean's List Award, and then within that, based on your club's account with you. Yeah, I don't have 2 chances for that.
Samuel was
He
an
yells at me a lot.
excellent
All right. Okay.
Once
So
me with the jigsaw.
on your own time, you guys take a look at those awards and decide amongst yourselves what you want to do. Okay. Unless you bring it up, that's the last I'll ask you guys about it. Okay. Okay. So let's talk about fun stuff.
Fun.
Yeah. How many of you guys actually took physics class?
The sleeping in it count?
Oh, yeah, me too. You like my interesting
No,
thing
alright,
at science for,
everybody
right?
does physics, right?
Nothing.
Oh, yeah.
Okay. So, important thing when you take any class like that, right? Don't just memorize all those formulas they throw at you.
I
Know
don't.
what to plug into what variable, right? Try to understand what the formulas mean, the concept that they're trying to teach you, right? Very important one for us is right? You guys all have seen that before?
Yeah.
Force equals mass times acceleration, right? Y'all know what acceleration is? It is.
derivative.
Third derivative.
But in English words, just what is the concept of acceleration?
Change in velocity.
Change in velocity,
Oh,
right?
yeah,
So
that's
what is
what it
velocity?
means.
In colloquial
Speed
terms,
and direction.
Standing still up. I guess speed.
Speed and direction.
Speed and direction.
Change in
Distance. Position.
distance over
Position,
time,
whatever.
right?
I thought that's
Or
displacement.
displacement of
Whatever.
distance over time, okay?
Don't over science it.
You guys know about Newton's laws of physics?
I just remember Jerry posted that picture. Oh, first law of motion.
Oh, yeah.
Uh,
Object at rest stays at rest. Object
Right.
motion.
First one is inertia, second one
Yeah,
is
okay,
F
okay.
equals ma, and the third one is
Action reaction.
Good for you.
So the first one, right? Momentum wants to stay the same. So if something is at rest, how much momentum does it have?
Zero.
0, because momentum is what? Mass times velocity, right? So if that velocity is 0, the momentum is 0. And it wants to stay there, right? Unless you apply this force, which will accelerate the mass, right? And then its velocity will start to change, okay? Now, where was I going? Right, so now we have a robot, right? This robot has mass. And what do we want to do with it?
Accelerate.
Make sure
We
it's
want to
not on
make
top.
it, huh? We want it to have a velocity, which means move across the floor. So we're going to apply a force to it. Well, how do we do that?
We attach motors.
Motors, right. Why motors?
Because they convert.
Air power is just too old school.
Because
Well,
they convert electrical energy into
just flowing
mechanical.
air. That would work. I mean, you could, right, invoke the third law of action reaction,
Because they convert electrical energy to mechanical energy.
right? Okay.
We need a curse
From
system on a
tempo.
robot.
Curves.
Yeah. It's a kinetic flywheel, and every time you want your wheels to move, you latch onto
The
it.
kinetic energy recovery system. I thought it was electrical.
It
In
uses-
Formula One, it's electrical.
No,
It's actually
they
a
have it in
giant
mods.
Hmm?
It might be. No. It just stores it in a flywheel. I think it converts that to electrical energy, maybe. I don't know.
No, because
It's
there's
off of the
always
braking.
electrical problems with it. So,
Well,
anyway,
we're not using it on
Anyway.
Sorry.
In
So-
other words, okay.
we have a motor, right? Motor has a shaft that rotates. You guys know what torque is?
Force applied to circles.
It's a rotational force,
Yeah.
right? And its units are expressed in what?
Newtons times.
So it's a
Distance.
force times a distance, right? So the way you can think of it is if you had a lever arm on this, rotating on this axle, and say you have, you push on it, right, with 1 pound force here, and this is a foot away. The amount of torque that you're applying to this axle here is 1 foot down, okay? Now, instead of pushing on this end, you actually have the motor try to rotate this bar, and this bar is still 1 foot long. And you turn on the motor, and give it enough voltage that suddenly you have this, the end of this bar pushing down with 1 pound of force, right? You could say that the motor is putting out 1 foot-pound of torque.
Ideally, right? In an ideal situation.
Well, if you, right, if this is actually 1 foot and you're actually measuring 1 pound of force, right? That is what you're actually getting out. The only time you would talk about whether it's an ideal situation or not is if you're looking at the efficiency of this motor, right? So how much energy are you putting in and how much work are you getting out of it? Okay. Because some of that energy will go to heat, some will actually go to kinetic energy coming out. Let's see. So, right? So we got this motor, and it's going to be powered by our 12-volt battery. Right? So how come we don't just take a wheel and stick it on the end of this? Right? Stick it on the end of this motor and be done. That'd be pretty simple, huh? Be pretty simple.
I'm
That's
just
the
very
info.
blind. Don't worry
Huh?
about it. I'm just blind.
Okay. So how come we don't just do that and be done? Take a motor, stick a wheel on it, mount it to the robot, and be done.
Because you might need to power more than one wheel with the motor.
Okay.
Just the
That's fine.
Motors.
Connect several together with gears or chains or
oh,
belts or whatever.
Control the speed and on and off switches to control the stopping speed.
It may not even go at all. That's your problem. Right?
So we can-
Because this motor puts out way less torque than you're going to need to rotate this thing. Right? So this thing could end up weighing about 120 pounds. You need to push it. Right? The wheels need to push on the ground and push this thing forward. Let's see. So, when you look up the torque curve for the sim motor,
Are these the 4 inches, Kimmy?
Oh, what? I believe so. I don't know. It's
Whatever the big ones.
Whatever. Big ones.
Yeah, I think they're the 4 inch ones.
Uh-huh.
Okay, so here's our bot. We got our, how big is our wheel?
6 inches.
6 inches. And what's our current gearing? Right, because we've got a sprocket. Sprocket on the wheel, what's, how many teeth are on the sprocket?
I don't know, 16 or more.
You don't know?
I think this one's 16, that one's 16,
Can you-
not sure. Oh, fine, I haven't counted.
Real quick.
Yeah, various sizes.
I want to know, right,
Yeah.
the size of that sprocket, right? That sprocket's being driven by another sprocket, right? That's on
Oh,
the tough
that
box.
chat sprocket.
right?
Yeah,
And that tough box
yeah.
has some internal gearing, right? We'll just assume that it's, you know, another sprocket. Can you quickly count those? Find it yet, Sam?
Or not on any actual fish for stuff. Or what?
Okay.
2.22, 2.22 whatever Newton meters. That's what it says here now. Or
What?
Pretty much
So
like-
sim,
or that's the stall torque.
stall torque is what?
2.22 Newton meters. But that's off of Chief Delphi.
Oh.
So that's why I
Newton-
haven't really found it yet.
How many newtons in pound?
This is 2.42 off of Andy Mark. Yeah, doing the gear ratio discussion right now.
Oh.
Remember seeing that? Nope. Oh, sure. I'm just searching.
So there should be somewhere a, oh, yeah.
I'm just found this.
Okay.
So that's ounces.
So 1 minus stall.
No, stall's gonna be so this is, and then what is this? That
Maybe grand. So there's a stall. There's a stall.
bias, that's all.
You want me to count it?
1522 at the moment.
What's this?
It has the stall curve. 133 amps.
Okay.
Yes, and that's about 133.
Okay, so for an electric motor, they have what you call a torque curve. So as the RPM, the rotational speed of the motor increases, right, the amount of torque that it's able to put out decreases. Okay? So the most torque it puts out is when it's first starting out. Okay? So the concept you need to take away from this is that, right, when you first apply power to your motor. It's going to have a certain amount of torque, and that will translate to a certain force that it's able to push the robot with and begin it to start its accelerating. So your acceleration will be at its maximum, because this is the most torque you can get out of the motor. It's when it first starts moving. Okay, so as the motor starts to speed up, and as your robot starts to accelerate, this acceleration will actually go down because this force goes down as this torque goes down. So at some point, the amount of force that your motor is able to apply to the robot will equal all the drag on it, all the rolling resistance of your roller chains, your bearings, the carpet, the wheels, okay? And then you'll stop accelerating and you'll reach a maximum speed. There are calculators that figure all that stuff out. I don't know the exact formulas to figure all that out.
And Cody's not here.
Yeah.
Just like Viola.
But the concept you need to understand is that, right, you'll get your maximum acceleration once you start, and then it will slow down. Your acceleration will slow down until it reaches zero, and then you've reached your terminal velocity. So, the reason we can't just take a motor and stick a wheel on the end of it is because even though when we first start out, right, our torque is at its maximum, that's not going to be enough to push this 100-pound or 120-pound robot as fast as we want it to go, okay? Or accelerate as quickly as we want. So the way we get more out of it is by reducing the gear ratio, right? So let's just do one stage, okay? Just as an example. Say we have our motor here, and we put a sprocket on here that has 10 teeth, okay? Then we have another one over here, sprocket over here that has 30 teeth.